Assalamualaikum warahmatullahi wabarakatuh. My name is Fatin Nazirah binti SANI, AE 170057. My supervisor is Professor Madya IR Dr. Dirman Hanafi. The title for the FYP project is 15 kVA 11 kV to 400 volt transformer winding fault detection using sweep frequency response analysis, which is SFRA. For the introduction, the problem statement is the power transformers provide safety to the electrical systems, but it also has weakness that not only damage the efficiency of the system, but also face unplanned outages and also other unexpected failures even after the periodic maintenance. The major cause of the failure happens in the transformer winding can be due to the aging of the insulation as well as short circuit problems. The issues will be overcome by developing the FRA method that will help to detect and diagnose the fault of the power transformers. This method will detect the winding deformation by applying the sweep frequency response to the winding. Sweep frequency response analysis also will simulate using MATLAB or SIMULI software, and its result will be used to analyze whether it is in unfault condition or fault condition through evaluating the frequency variation in the transformer winding. Next, for the objectives, firstly, to develop the frequency response analysis by using MATLAB or SIMULI software. Secondly, to diagnose the transformer winding fault using frequency response analysis method by applying the sweep frequency response analysis. And thirdly, to compare the results of fault condition with reference to the unfault condition. The scopes of the study: firstly, the transformer winding fault we diagnose using FRA method by applying the sweep frequency to the winding. The diagnosing will be simulated using MATLAB or SIMULI software by analyzing the short and open circuit in the transformer winding. The transformer rating that will apply in this project is a 3-phase system 15 kVA and 11 kV to 400 volt. The simulation of SFRA will produce waveform of interturn fault, turn-to-turn fault, and also change the ground capacitance that will show the significant waveform conditions are changing compared to the unfault condition waveform. And lastly, the transformer will be assumed in a healthy condition when there is no changes of the waveform. Next, for the literature review. This is the summary from the previous research. Firstly, the method for transformer winding fault detection. This research is fast, simple, and sensitive, and it also needs a complicated noise filter for filtering the signals. Next, fault investigation of transformer windings using the frequency response analysis, which is FRA. It is a model of first coil by resonance cells and measured experimentally, and any failure that has happened in the coils results in the difference of the coil impedance in function of frequency. Thirdly, a review of frequency response analysis methods for power transformer diagnostics. It has a low sensitivity and also the combining the FRA and also the impedance methods to diagnose the winding. Continue from the previous research, the research of sweep frequency impedance to determine the transformer winding deformation after short circuit impact. It is use of SFI to test the curve of high voltage winding, and also it can produce a little changes to the transformer winding. And lastly, fault diagnostic in the transformer winding by sweep frequency response analysis. The calculation of similarity and also dissimilarity, which is it's not require large number of experiments, and the ANN and wavelet software is required a large number of processes and instruments. Next, for the methodology, this is the project flow design that we need to consider to complete the project. Firstly, we start with literature review. Next, we diagnose the transformer winding by applying SFRA in the transformer winding. Next, we construct the SFRA circuit using MATLAB or SIMULI software. Then, we test the circuit to see whether it is fulfill the requirement or not, and then after that we collect the frequency and also the current value for further analysis and discussion. Next, this is the proposed model of sweep frequency response analysis. The measurement of SFRA in normal and a fault condition are collected from the simulation, and then we compare the results in a waveform, and from the result waveform we identify the fault. For the results and analysis, this is the circuit of transformer winding for normal or unfault conditions. And this is the board diagram of the simulated SFRA. The first resonance after the simulation of the transformer model is occurring at 440 Hz. The magnetic effect of the points begins to rise, but the winding inductance effect is monitored after the first resonance point. This method is continuously repeated several times so that the medium frequency range provides more resonance points. And the current obtained from the waveform of the winding is 0.7762 ampere. Next, this is the intermittent fault conditions. The short circuit is occur at winding 2 here. And this is the board diagram for the simulated SFRA. The waveform displacement performed from the board plot is slightly increased compared to the unfault condition, which is from absolute 0.0028 to 0.00293. The first resonance after the simulation of the transformer model is occurring at 450 Hz. A 0.7948 ampere of current is measured, which is higher than the unfault condition. The increased current releases an abnormal hitch, which affecting the transformer insulation and causing the winding to burn out. Next, for the turn-to-turn fault condition, this transformer winding is short circuit at winding 1 and 2 here. And then this is the simulated SFRA. Okay, the board diagram shows the slightly increased waveform displacement occurred compared to the unfault conditions, which is from the absolute 0.0028 to 0.00295. The first resonance point is observed at 450 Hz as it is completely displaced compared to the unfault condition. The measured current is 1.02 ampere, where it is increased by 0.2438 ampere from the unfault current condition, which is it thermally stressed the insulation. Lastly, this is the test for the change of ground capacitance conditions. All the ground capacitance is changed to 52.6 picofarad. And this is the board diagram for the simulated SFRA. The significant waveform displacement occurs after the value of capacitance is changed from absolute 0.0028 to 0.134. The waveform from the board plot is completely collapsed due to the capacitance is inversely proportional to the frequency. The first resonance point is appeared at 189 Hz, while the simulated current is limited to 0.6284 ampere, which is lower than the reference condition. Therefore, the lower capacitance value reflects the lifespan of the transformer span due to the lower frequency resonance. For the conclusion and recommendation, the conclusion is the objective is achieved and compared with the result obtained from the simulation. By using MATLAB software, or Simulink software, the FRA can be developed by applying the sweep frequency to the transformer winding. From the unfault condition, it can be concluded that the first resonance after transformer model simulation occurs at 414 Hz. The intermittent fault condition, the first resonance for 415 Hz occurred at the second winding. For the turn-to-turn fault condition, it is concluded that 415 Hz of the first resonance occurred between the first and second winding. Lastly, after changing the ground capacitance to 52.6 picofarad due to the changing of length between windings to 0.0209 meter, it is recorded that the first resonance will occur at 189 Hz. For the recommendation, firstly, the rating of the voltage source from the transformer model can be changed into larger value to get the bigger current value as well as its resonance point and also magnitude. By adding and developing a new block for Simuli software, such as using a fast Fourier transform analysis block, as it is easy to find the frequency domain of the transformer winding model instantaneously. And lastly, hardware developing for sweep frequency response analysis study are the most recommended for the next study by using double M5100 test equipment that it can deliver a reliable, durable, and also consistent findings. That's all from me. Thank you for watching.